So our next talk will be by Stojan Madzunkov, and he will talk about the Lunar Q-stat mass spectrometer with linear energy transfer spectrometer radiation sensor.
Hi, can you all hear me?
I can hear you.
Great. So these are two instruments in one, in a sense. So Lunar Q-stat mass spectrometer is neutral mass spectrometer, and we have also radiation sensor on it. This is concept we proposed for DALI, which is now funded this year. We start working, and in 2 years we should be basically ready in 3 years tested to TRL6 level. The team, I'm leading the mass spectrometer development. Dan Fry from Johnson Space Center is leading the radiation sensor. And there is also people from University of Michigan, specifically Space Physics Research Lab. I will not talk about LETS at the moment. It's also funded to other project called CLIPS, and it's supposed to be on the lunar surface at 2021 if everything goes well. Next slide. So this is a little bit of history. We are developing this mass spectrometer for a very long time. These are two projects that is developed on for ISS. We have instrument there first in 2010 as a VCAM, Vehicle Cabin Atmosphere Monitor. And then after that, there is Successor, which is much smaller, much more compact, but still very similar sensor, which is now at space station measuring. And technology that is inside is basically the same we are proposing for lunar vision. Next slide. So this is a little bit of science. I don't want to go into that except to keep in mind that at the moment we are neutral mass spectrometer. We only look at the neutrals in the lunar exosphere. So our key aspect here is that we are very, very sensitive and be able to see it. And we are sensitive enough that we can see on the per second or per minute basis. And we also believe that with that measurement coupled with the radiation information can give us some very insightful information of how the exosphere is formed. Next slide, please. So this is our technology readiness chart. We are basically at the moment just spinning up the final version of electronics, which is based on the prototype you will see on the next slide. This is the picture of how the sensor look like. It's inside a titanium plated chamber. It's very compact, as we heard on the previous talk. It's like this one, for example, is designed for and tested for 60 G axial load, so it's very, very robust. You can really drop it on the ground; it will still work. I will not go into the how it works because it's already described. So next one. Next slide, please. So this is just a picture of the prototype we developed pre-DALI, and we are basically going from this into the DALI. This is just, I can just tell you, it's going to be inside the 6U. Next slide, please. So this is some of the science, what we can do. So we are very, very sensitive mass spectrometer. And I will show you just a few graphs so that you can realize that. So next slide, please. So these are just measurements directly just to show you from oxygen isotopes, argon isotope, carbon isotope, and argon directly from air. I cannot go into the details. There's no time, but these are all published results, so people can look up to it. Next one. So this is also, you have a publication below. This is measurement of the isotopes from the zirconium sample. It's not air is not Earth sample. The first slide shows you one shot. It's about 50 milliseconds to take it. And the partial pressure of xenon here are 10 to minus 11 torrs. So, and the bottom slide text shows you what you can do in 1 minute. So I just want to underline here, we did not build this mass spectrometer as a mass spectrometer to go to the moon and do some specific thing. This is
30 seconds left.
as powerful as mass spectrometer you have in your labs. If you buy big magnetic sector mass spectrometer, he will have comparable quality of this one. So, for example, in 7 hours continuous measurements, you come to 0.6 per mil precision on isotope ratio on krypton. Next slide. And this is, we have developed software to simulate what our mass spectrometer response would be. And this would, what we expect to be able to measure on the moon within 5 minutes and 20 minutes. So we will be able to see in a very short period of time, basically all the components of the exosphere, if prediction of the exosphere are correct. Thank you.